All right, this is the third podcast for Chapter 1. And we're going to look at 27, 28, 35, 36, and 39. Now, 27 and 28 are order of estimation problems. That means that we don't have to be exactly perfect with some of the factors that we use. So, let's look at number 27. And let's estimate how long it's going to take this guy with a mower to mow our football field. Well, so we know about our mower. He mows at a speed of 1 kilometer per hour. In other words, in 1 hour, he can mow 1 kilometer. And the width of his mower is 1/2 meter. All right. So now let's look at our football field. Keeping in mind that we can estimate because we're doing an order of estimation problem. So let's estimate that our football field is 100 yards long. We're not even going to worry about the end zones. A yard, that's almost like a meter. So let's change 100 yards. And let's estimate that our football field is 100 meters long. A typical football field is 160 feet wide. Again, since we can estimate, a foot, a regular ruler, is more or less 30 centimeters. So 160 feet would be 4,800 centimeters, or 48 meters. And those are the dimensions of the football field that I'm going to work with. All right. Our field is 100 meters long. He mows at a speed of 1 kilometer per hour. So, how long is it going to take him to travel the 100 meters? 100 meters, that's 1/10 of a kilometer. Kilometer is 1,000 meters. 100 is 1/10 of that. So, keeping that in mind, it's going to take him 1/10 of an hour to go down the field. Now, he can't just go down once because remember, his mower is only 1/2 meter wide. The football field is 48 meters wide. That means it's going to take him 96 trips down and back, down and back, in order to cover the whole field. Each trip, remember we estimated, is about 1/10 of an hour. So that means it's going to take him 9.6 hours to mow this field. And that's our estimation. Number 28 deals with people again, and it wants us to estimate about how many liters an average person drinks in their lifetime. So we're going to know something about people. Well, in order to be healthy, you're supposed to drink 8 glasses of water every day. What's a glass? Well, let's say that a glass is 8 ounces. So we're going to estimate that the average person drinks 64 ounces of water per day. But it doesn't want ounces. It wants liters. So here's where our estimating comes in again. I said a liter. Well, that's more or less like a quart. A quart is 32 ounces. So 64 ounces of water a day means 2 quarts of water per day. Or, more or less, 2 liters of water per day. So in other words, you should drink a 2-liter bottle of water per day in order to be healthy. But you don't just live a day, do you? The average human, let's say there's 70 years for the average life expectancy. In 1 year, there are 365 and a fourth days. And remember, each day we're supposed to be drinking 2 liters of water. Do the math out, and you should get around 49,000 liters of water. So you drink about 49,000 liters of water in your life. That's if you're drinking, of course, a 2-liter bottle every day. And that's number 28. Now, let's take a look at 35, which doesn't involve any estimating, thank goodness. What we have is a 30 centimeter cylinder. And we're going to get some computer chips out of it. It tells us the thickness of a typical computer wafer in millimeters. So the first thing we had to do was change centimeters to millimeters. There are 10 millimeters in 1 centimeter. Each wafer is 0.6 millimeters thick, and we get 100 chips for every wafer. Work out the math, and you should have gotten that's 50,000 computer chips from the 1 cylinder. All right, number 36 wants us to know how many seconds there are in a year, and then how many nanoseconds that would be, and then how many years are in a second. All right, here we go. 1 year is 365 and a fourth days. There are 24 hours in 1 day. Now, we could do what we've been doing, which is our 60 minutes in 1 hour, and then there's 60 seconds in each minute. Or you could just remember there are 3,600 seconds in 1 hour. And when you multiply all that out, you get 3.16 times 10 to the 7th seconds in a year. Now, we need to convert that to nanoseconds. Well, each one of those seconds has a billion it's 10 to the 6th nanoseconds Nope. 10 to the 9th nanoseconds. And so that works out to be 3.16 times 10 to the 16th nanoseconds. Then it wants to know how many years are in a second. Hey, you know what? That would simply be the reciprocal of how many seconds were in a year. So, take the reciprocal of this number and you get 3.16 times 10 to the negative 8th years in 1 second. And that is number 36. Now, last but not least is number 39. 39 wants us to use some information on table 1-3 to estimate the total number of protons or neutrons in a bacterium, a DNA molecule, the human body, and our galaxy. So, looking at that table, it tells us that proton and or neutron is 10 to the negative 27th kilograms. A bacterium is 10 to the negative 15th. A DNA molecule, 10 to the negative 17th. A human body, 10 to the 2nd kilograms. And our galaxy, 10 to the 41th kilograms. So now it's really just a matter of taking each one of these and dividing by 10 to the negative 27th. Hey, I remember when you divide exponents, you simply subtract. So negative 15 minus negative 27, well, that would be 10 to the 12th protons and or neutrons. 10 to the 10th, ten to the 29th, and 10 to the 68th. And that was number 39. Very straightforward, very easy, I thought. Actually, I thought it was the easiest problem in this section. So, that's podcast number 3.